Thank you. So we have our last presentation left. It's gonna be environmental analysis of the methanol as an alternative marine fuel. That's gonna be presented by Maja Perčić. So if you're ready, you can start, Maja.
Yes. Just, okay. Just a moment. What? Okay. So hello everybody. My name is Maja Perčić and I'm a PhD student at the Faculty of Mechanical Engineering and Naval Architecture at the University of Zagreb in Croatia. Today I'm going to present you a paper called Environmental Analysis of Methanol as an Alternative Marine Fuel. First, I'm going to introduce you to the research background, and after the methodology, the results of the research is going to be presented and conclusion is going to be stated. One of the most environmental problems nowadays is the air pollution caused by extensive use of fossil fuels. Well, fossil fuel combustion causes exhaust gas that comprises of nitrogen oxides, sulfur oxides, particulate matter, carbon monoxide, and greenhouse gases, which refers to emissions of carbon dioxide, methane, nitrous oxides, and fluorinated gases in low concentration. Well, among different transportation modes, the road transport has a major impact on the transportation emissions. The maritime sector should not be neglected, especially when the negative impact on human health is more pronounced when ships spend much more time near ports and near populated areas, such as ships engaged in short sea shipping do. Regarding the impact of the emissions, the nitrogen and sulfur oxides have a negative impact on the human health, but also on the environment, causing its acidification, while the greenhouse gases have a negative impact on the environment, causing the global warming. The relevant climate agreement, the Paris Agreement, promotes the reduction of CO2 emission, as the CO2 is a major greenhouse gas. This reduction of CO2 emission is often called decarbonization. And according to this Paris Agreement, each sector should participate in its decarbonization. So according to the Paris Agreement, the International Maritime Organization set a new goal for international shipping to reduce its annual greenhouse gas emissions by at least 50% by 2050 compared to 2008 level. Well, the most promising way to reduce greenhouse gas emission is to replace the conventional fuel with alternative, preferably with a zero carbon content, but it's okay if it's a lower carbon content. So among different fuels that are investigated for the use in a shipping sector, methanol is one of them. So methanol is a sulfur-free fuel with low carbon content. Its lower carbon content leads to lower released greenhouse gas emissions. Methanol has a carbon content around 38%, while for the comparison, diesel has a carbon content around 87%. So there is a great difference in the released emissions. Methanol can be produced from various sources, either fossil methanol or biomethanol. Fossil methanol can be produced from fossil fuel, either natural gas or coal, and it's available and affordable fuel, but it's still fossil fuel. On the other hand, we have biomethanol. Biomethanol is produced from biomass, and it is biofuel, which is usually considered carbon neutral fuel, but its main limitation is that it is expensive and the distribution chains are not so developed. Due to similarity with conventional marine fuel, methanol can be used in existing infrastructure with just a minor modifications regarding low flash temperature. While it can be used in the commercially available dual fuel engine, methanol can also be used as hydrogen carriers in fuel cell systems. In this paper, several methanol types as a potential marine fuels are investigated depending on the methanol origin, whether it's fossil methanol or biomethanol. Well, in this paper, the fossil methanol is produced from natural gas, while there are 6 different types of methanol, and they are produced from willow, switchgrass, forest residue, corn stover, miscanthus, and poplar. The life cycle assessment comparison of the total greenhouse gases, NOx and SOx emissions related to considered fuel, where the currently used diesel-powered ship represent a baseline scenario, and the results of the analysis are illustrated on the ship engaged in the Croatian short sea shipping sector. The environmental impact of diesel and different types of methanol implemented on board are investigated, where the selected ship is a Ro-Ro passenger ship, i.e. ferry, that is engaged in the Croatian short sea shipping fleet. On the left side of this slide, it is presented the methodology flow. In the first step, there is a ship schedule analysis, which will lead to average speed calculation. The third step of the methodology is energy needs analysis, which lead to energy consumption calculation. So energy consumption calculation represents an input parameter for our life cycle assessment software, which is agreed 2020. After that, the life cycle assessment of diesel and life cycle assessment of different types of methanol are performed, and in a final step of the methodology, they are compared. On the right side of the slide, the representative of the Croatian short sea shipping fleet is presented. This ferry operates between 2 settlements, Ploče and Trpanj, and it represents a good candidate for implementation of such alternative fuels such as methanol, due to the proximity of the land, required energy, and the length of the route. So environmental analysis is performed with life cycle assessment, as I stated before, with this LCA software GRID 2020. This environmental assessment considers emissions released through the life cycle of a ship power system, where these emissions can be arranged into 3 phases. First phase is a well-to-pump phase, which refers to emissions related to the fuel cycle. It includes processes from raw material extraction to transportation of raw material to production facility, production fuel, and finally distribution of that fuel to the refueling station. The second phase is pumped wake phase, which refers to the emissions related to the use of fuel in the ship power system, which often refers to the use of fuel for ship operation, combustion of fuel in a ship engine. And finally, the third phase is manufacturing phase, and these emissions are related to the manufacturing process of the main element of a power system, for example, a diesel engine, battery, fuel cell, and so on. So in this paper, total CO2 equivalent emissions, NOx, SOx emissions are investigated to the 20 years of a ship lifetime. In the life cycle assessment of a diesel-powered ship, the processes that are included are diesel engine manufacturing, crude oil recovery, crude oil transport, diesel production, and diesel distribution, and finally combustion of diesel. Well, in the life cycle assessment of methanol-powered ship, along with dual fuel engine manufacturing and combustion of a fuel in a ship engine, we have 2 well-to-pump phases. First one is from methanol, and the second one is of diesel. Since methanol is used in a dual fuel engine, it requires pilot fuel, in this case diesel, to start the combustion. So in a small share, diesel is used as a pilot fuel. In the well-to-pump phase of methanol, the processes that are included are feedstock preparation, methanol production, and methanol distribution. Finally, the results of the life cycle comparison indicated that even fossil methanol is environmental friendly option compared to diesel powered ship, and that regarding the greenhouse gas emissions, biomethanol represents even more friendlier option than fossil methanol. But regarding the NOx and SOx emissions, the comparison shows some types of biomethanols have higher emissions than fossil methanol. Due to that, the further analysis is performed where the well-to-pump phases of each type of methanol, including fossil methanol and biomethanols, are compared, and this analysis indicated that biomethanol produced from forest residue represent the most ecological option among analyzed. Its use as a ship fuel resulted in lower SOx emission, NOx, and CO2 equivalent emissions. Regarding the CO2 equivalent emissions, fossil methanol has the greatest contribution to the global warming among considered types of methanol, which is obvious. When observing the NOx emissions, the highest has the biomethanol produced from poplar, while it's evident that the production of biomethanol from switchgrass has the highest SOx emissions. In conclusion, methanol is investigated as a marine fuel used in a dual fuel engine on board short sea, on board the Koričan ro-ro passenger ships. Along with fossil methanol, 6 different types of biomethanols are investigated. Their environmental impact are investigated and compared with the existing power system on board a ship. The life cycle assessment comparison showed that even fossil methanol is the environmental friendly option compared to the existing diesel-powered ship, while among different types of methanol, biomethanol produced from forest residue show the lowest emissions. And methanol and either fossil or biomethanol offers lower emissions during the ship operation, and it will be reduced to environmental footprint of the Koričan ro-ro passenger ship. However, further development of bunkering facilities and distribution chains of methanol are required in the future. And thank you for your attention.
Okay, thank you for the nice presentation. It was our last paper in this session. Do we have any questions for Maja? No, we don't have. Do we have any questions from Claire, DeMarco? I think no. So it's the end of the session. I'm going to close the session. So thanks again to everybody for your nice presentations. The second, we will have a break right now, and after that a special session will be started. And after that, for the papers presentation, it's gonna be start at 7:15 according to Turkey time, and 4:15 for Central European time. You can join that sessions. The session subject is materials, so you can follow that session at 7:15 according to Turkey time. So thanks again, everybody, for joining our Congress. So see you in next sessions.